Meanwhile, please do this question and let me know what are you getting. This is from polynomials, okay? So if the sum of the roots is minus p and the product of the roots is minus 1 by p, then the quadratic polynomial is please do it, no? Okay, I can see all the important questions from quadratic equation. We have already discussed nature of the root. Based on that, have we done few questions? Please confirm. Yes. Have we done question which is related to nature of the root? Okay. Please do it, no? Have we done this type of question, the quadratic equation x square minus 2kx plus 5k is equals to 0 has equal roots when k is, have we done this type of question? Yes or no? What you got from here? The polynomial, the quadratic polynomial. See, we can frame the polynomial by using the same formula, that is k times x square minus sum of the roots, which is directly given. We don't have to add this two. Okay, minus p, it's already written over here, that is the sum of the root, into x plus product of the root, that is minus 1 by p. Okay, this is the polynomial we are having. Here sign and everything is there, so minus minus plus, these are the things we will just write it here, plus minus minus 1 by p, and like this only we will leave the polynomial. Any confusion to anyone? Any
No, ma'am.
confusion? No. Okay, please do this one. No, have we done this type of question, that the quadratic polynomial, quadratic equation is this, has equal root, then we are supposed to find the value of k. Please find it. And do this one also, one more question which is based on nature of roots.
Ma'am, no, we didn't do the nature of roots revision.
Yeah, what are you getting k value as?
No, I'm saying we didn't do the nature of roots revision.
Oh, can you please repeat?
No, I'm saying we have to do the nature of roots revision.
Yeah, nature of the root we don't have to check. We have to find the value of k. The quadratic equation has already written over here equal root. We have discussed it in class, right? Nature of the root we have discussed in class, right? Yes or no?
Yes, ma'am.
Okay. So we have discussed, it already says that the roots are equal. Okay. So that particular case we will be taking, and from there we will be finding the value of k. Anyone who has already found the value of k? Anyone? Anyone who has already found? Okay, let's do it. Let's do it. It says that the quadratic equation this has equal root. There were three formulas, okay, three condition, that if b square minus 4ac is greater than 0, then roots are real and distinct. Okay, roots are real and distinct. Distinct means different. Next one, when b square minus 4ac is equals to 0, then roots are real and same. And the last condition was when b square minus 4ac is smaller than 0, then roots are not real. Okay, these were the three condition, or you can say three rules we were having in hand. Here it is already mentioned that roots are equal. Okay, we are having equal roots. So basically we are talking about the second scenario. Okay, roots are same. This is the scenario where the roots are real and same. Real means real number. Okay, roots are real number and are same. So we are talking about the second case. So if the question is talking about the second case, then directly we can take b square minus 4ac is equals to 0. By ourselves we can take, because it says that roots are equal, and that scenario is b square minus 4ac is equals to 0. Now what is b, what is a, what is c? Who will say? Anyone who can say what is b, what is a, what is c from the given quadratic equation?
Ma'am, B is minus 2.
Yes. B is
B is minus 2.
minus minus 2k, right?
Yeah, minus 2. Okay.
Okay, minus 2k. Minus 4 into a is just, a is,
A is 1.
and c is,
C is 5.
it
5K.
is 5 or 5k, yeah, 5k.
5K.
K is equals to 0. Please find k value from here. Please find k value.
Ma'am, K is 16.
Yes, everyone is getting k as a 16. Here we can take 4k common, and we will be having the factor k minus 5 is equals to 0. Please check. I can say that k is 0 or k is 5. It is not 16. Yes, rest of the student, are you even doing it?
Yeah. Yes.
What you got k as a
I also got K 16.
16?
Yes.
See, Bodma says first do the multiplication. So this are in multiplication. We will multiply all of them. Have you done the subtraction first or what? 4 into 1 into 5k. It will be 4 5 times 20. 20k we will be having over here. And 2k whole square will be 4k square. Yes or no?
Yes.
So 4k square minus 20k is equals to 0. Now here we will not cancel out k by shifting to another side and all. We will be careful. We will do the factorization over here. We will take the common factor. 4k is the common factor. And the remaining term will be k minus 5. Now from here we can say that either this k is 0 or k is 5. Yes or no? We are getting two cases over here. Can you see that we are getting two cases from here, that 4k is 0 or k minus 5 is 0. Okay, from here we are getting one of the k value as a just completely 0 because 0 by 4 is 0. Okay, 0 by 4 is 0 and here k is 5. So these are the two possible values of k. Are you getting it, everyone?
Yes, ma'am.
Now the next question we have to check the nature of the root. Here it doesn't say anything about the root, that roots are real, roots are same, roots are not same. Doesn't say anything. We have to check it whether the roots are real and distinct, whether the roots are real and same, whether the roots are not real. Okay, so this is the quadratic equation we are having. 2x square minus 4x plus 3 is equals to 0. This is the quadratic equation we are having, and you have to check the nature of the root by finding the discriminant. This b square minus 4ac is called discriminant. B square minus 4ac is having a name called discriminant. I am writing on the screen. Anytime in your question paper, if this terminology is reflecting discriminant is this, discriminant is that, that means you should understand that discriminant का मतलब होता है b square minus 4ac. Okay, so we will be checking b square minus 4ac whether it is bigger than 0, smaller than 0 or is equals to 0. Please do it now. Yes, what are you getting? The nature of the root. Is it real and distinct?
I got real and distinct. I got real and distinct. It's
You
above
got
you.
real and distinct. Let's
Yeah.
check it. 2x square minus 4x plus 3. Okay, Zunad has got real and distinct. We are having this quadratic equation is equals to 0. We will be finding p square minus 4ac. Okay, here b is clearly visible. B is minus 4 square minus 4 into a is 2 and c is 3. Okay, we are checking it that whether it is bigger than 0 or what. So 16 minus 4, 2 times 8, 3 times 24. 16 minus 24, negative we are getting, right?
Yeah.
Yes.
Which is smaller than 0. And for a smaller than 0, the last option, the last rule is if it is smaller than 0, then roots are not real, right? Right?
Yes. Yes.
Okay. So we will say that since when we calculated b square minus 4ac, it became smaller than 0. Hence, roots are not real. Okay. Now we are done with quadratic equation. I can see we can take trigonometry now. Just a moment. Please do it. No, prove that, and let me know. Are you able to prove it or not? Sine theta minus cos theta plus 1 over sine theta plus cos theta minus 1 is equals to 1 by sec theta minus tan theta. Just a moment, no. Please do it, no. Let me know, are you able to prove it or not? Are you done? Yes, Zunad, Afnan, Ayan, Adyan, Ifra, Alvina. Are you done? Do you know how to prove it? I have started trigonometry over here, like the revision. Do you know how to prove it? Please let
No,
me
ma'am.
know. Are you trying it or we can try it?
Ma'am, I'm doing 1 minute.
Yes. Okay, let's do it. Okay, let's do it. So here, if we will focus on the left hand side and the right hand side, can you see that tan theta is there? On the right side, tan theta is there. And on the left side, we are having sine and cos. So anyway, we will try creating tan. We will try creating sec, okay, from the left side. So if I am taking the left hand side as it is, that is sine theta minus cos theta plus 1 over sine theta plus cos theta minus 1. Our main goal over here, the main focus over here, to create sec theta or maybe tan theta. For that, what we can do, for that, can we divide, like this sine is there. If we will divide this sine by cos, we will be getting tan theta, right? So let's try creating tan theta from here. Let's try dividing the numerator and the denominator by cos theta. Okay. Now the question is, can we do that? Is it allowed over here? Okay. Can mathematically, is it correct dividing the numerator and denominator by cos theta? Yes, it is correct. Okay, it's correct. That is allowed. When we are having a fraction, we can do the multiplication with same number in the numerator and denominator. We can divide with the same number in numerator and the denominator. So yeah, we are not doing anything which is not allowed. This is allowed. Okay. So now we'll be having sine theta by cos theta minus cos theta by cos theta plus 1 by cos theta. Similarly, here we will be having sine theta by cos theta. Okay. Plus cos theta by cos theta. Basically, we have divided the numerator and the denominator by cos theta. Okay. So we are getting here tan theta. We are getting here minus 1 and we are getting here sec theta. So wow, we have created tan and sec. But are we closer to the proof? No. Still we have to work on it. Okay. So plus 1 minus sec theta. Now see the proof. 1 by sec minus tan is there in the denominator. So what we will do, one thing we can do, that tan theta plus sec theta we can write together. Basically, I am writing this one and this one together, and minus 1 I am writing over here. Okay. And tan theta plus 1 minus sec theta. This is how we'll be writing it. Okay. Now this minus 1, this minus 1, this one we will be writing here the identity which is related to sec and tan. There is a identity. We are having three identities in hand. Sin square theta plus cos square theta is 1. The next one, sec square theta minus tan square theta is 1. So we'll be using this identity, and at the place of 1 we will be writing sec square theta minus tan square theta. Okay. At the place of 1 we can write it. Here tan theta plus sec theta we will copy paste as it is over tan theta plus 1 minus sec theta. Okay, let's continue. So sec square theta minus tan square theta can be written as, just think about it, it looks like a square minus b square. So we can write a plus b in one bracket and a minus b in another bracket. Okay, so let's write it sec theta plus tan theta in one bracket and sec theta minus tan theta in another bracket. Okay, and here we'll be having tan theta plus sec theta. In denominator, we will be having tan theta plus 1 minus sec theta. Okay, now we can take out this common. See, this term is common. Tan theta plus sec theta here also we are having and there also we are having. This is the common factor we can take. Okay, so let's take it out. Tan theta plus sec theta, this is the common factor. And what are we left with? We are left with 1. We are left with minus, and we are left with that bracket sec theta minus tan theta. We are not opening the bracket, okay, because there is a minus sign in between. So carefully we will open the bracket by tan theta plus 1 minus sec theta. Okay. Over now tan theta plus sec theta we are having, and this one can be written as 1 minus sec theta plus tan theta. Okay. Now this 2 is getting cancelled out. Tan theta plus 1 minus sec theta. This 2 gone. Are we done with the proof? Let's check it. In proof, 1 by sec minus tan is there. Okay. Just a moment now. 1 by sec theta minus tan theta. And we have got tan theta plus sec theta. Let me check the question. Have I written it correctly or not? Or I have mixed two different questions. Just a moment now. Just a second now, let me confirm. The same question was there in our NCRT, right? Yes, it is correct. Okay. This is not misprinting. This is the same question. I have checked in NCRT also. This question you are having in NCRT as well. Okay. So still we are not done. Sec theta plus tan theta we have got, but still we are not done. We have to reach any way. We have to make this 1 by sec theta minus tan theta. Okay. Now suppose now we got stuck. We are not getting what to do. Okay. We are not understanding now what can be done with the sec theta plus tan theta to create 1 by sec plus tan. Okay. So think about it. If now only we will take the right hand side, if now only I will show you how to work on the left hand side, but if now only we will take the right hand side, that is 1 by sec theta minus tan theta. Can you understand that if we will apply the logic of rationalization, that like a minus b structure is there in the denominator, in numerator and denominator, if we will multiply with a plus b, the rationalization concept I am applying over here. Okay, sec theta plus tan theta, then in denominator it will become sec square theta minus tan square theta, and in numerator it will become just sec theta plus tan theta. And can you see from here the denominator is getting 1 and we are getting sec theta plus tan theta. Are you getting it? So either we can work on the right hand side like this, or the left hand side, whatever we have found so far, that tan theta plus sec theta is there in hand. We can multiply it with tan theta minus sec theta, not tan minus sec minus tan. Okay, and in the denominator also we can multiply the same. And we are done with the proof. Please check it. We are done with the proof. We will be having just a second. Just a second. Yes. So in numerator, can you see we are getting sec square theta minus tan square theta, and in denominator we are getting just sec theta minus tan theta. Can you see that? Are you getting it? Yes or no?
Yes.
Okay. So either like this we can do, or we can work on the right hand side. Basically, we are supposed to prove that left hand side, right hand side, both are exactly equal. Okay. Now the next question is, if angle A and angle B are acute angles such that cos A is equals to cos B, then we have to prove that, then show that angle A is equals to angle B. Will you be able to show that when cos A is equals to cos B, then angle A and angle B will be same? We know that. Of course, angles we can do the comparison and angle will be equal. But here we have to prove it. How will we proving it? Okay, so we can take the help of one right angle triangle. We can call it A, B, C like this. Okay, because here it says that A and B are acute angle. So C we can take 90 degree, and of course A and B will be acute angle. Now cos A is equals to cos B. Think about it. If we will be taking cos A, what will be the trigonometric ratio? The formula adjacent side over hypotenuse. So cos A, adjacent side, who will say, please tell me quickly, what will be the adjacent side according to the angle A with reference to angle A? Yes. Will it be AC? Adjacent side will be AC
It
with
will be
reference
AC.
to angle A, and hypotenuse is AB. Similarly, yes. If we'll be talking about cos B, if we are focusing on angle B, at adjacent side is BC and hypotenuse is still AB. Okay, and if it says that cos A is equals to cos B, if we will do the comparison like that,